Welcome back. In this video we will talk about the SQL injections. So what is an SQL injection? It is a critical web security vulnerability that allows an attacker to interfere with the SQL queries that an application sends to its database. So the attacker manipulates the input fields, for example the login forms or the search boxes, and then alter the logic of the SQL queries. This type of attack can lead to different scenarios, for example, unauthorized access, data leakage, data manipulation, and in some cases complete system compromise. So we can say that the SQL injections typically occurs when the user inputs are not properly sanitized, so they are directly concatenated into SQL queries by the backend application. Now we will see a common scenario, the login page abuse. So consider this type of login page, the classical one. So you enter the email and the password and then you try to log in. So let's say that the backend runs a SQL query like this. So we can see that it selects all from users where the email is equal to what the user has put into the email field, and the password is equal to what the user has put into the password field. So as a regular user, you try, for example, these common combinations, admin, admin, but of course they are not in the database. So since they are not in the database, the credentials are not correct. So you get an access denied. But what if the input is crafted maliciously? So you don't need to know the email and the password to access the database. And this is what an SQL injection does. So how does this work? So the SQL injection leverages improper handling of input data. If the application doesn't escape or validate user input, the attacker can inject arbitrary SQL code to alter the intended behavior of the query. For example, let's try to inject this into the email field. So, or 1 equal 1 dash dash with a single quote. And let's leave the password field blank. Now the backend might execute the following query. So it selects everything from users where email is equal to none or 1 equal 1. And this is why it's dangerous, because or 1 equals 1 evaluates to true, and it's always true. And the dash dash tells the database to ignore the rest of the query because this is a comment. So if the system checks only for the presence of a result, access is granted, potentially as the first user, often as the administrator. There are different types of SQL injection attacks. We can have the authentication bypass that gains access without valid credentials. We can have the data exfiltration that extracts sensitive data such as emails, credit cards, passwords. We have the data manipulation that inserts or updates or deletes records maliciously. We can have a blind SQL injection that exploits SQL injections even when the errors are not shown by an observing behavior. Then we have a time-based SQL injection, which uses time delays to interfere query results. And then we can have out-of-band SQL injections that uses alternate channels, like for example DNS or HTTP, to extract some data. And finally we have the remote code execution. This is not very common, but SQL injections leads to shell access or command executions, especially in systems which are not properly configured. Of course, this type of attack can lead to different scenarios, different consequences. We can have a full control of the database in the worst cases. We can have the access to confidential informations, so not the whole database but just some parts. And we can have a website defacement. We can also have a compromise of internal systems, so we can access internal machines connected to the database, and we can have regulatory violations and financial loss. So the SQL injections, has been at the core of many high-profile breaches, and it's not as common as some years ago because there have been a lot of patches, but it still remains listed in the always top 10 as a major threat. So how can you prevent SQL injections? Well, you can use prepare statements. So instead of embedding user input into SQL, you can use placeholders, for example. And this works with most modern languages and database libraries, for example, Node.js and Python. You can also use stored procedures, so you can encapsulate queries on the database side, limiting dynamic SQL usage. Then we have the validate and sanitize inputs. You can enforce input validations, so emails must be valid emails, numbers must be valid numbers, and so on. And it's prefer white listening over black listening. And you should never trust client-side validation alone, so you always need to validate server-side. You can also apply the least privilege principle, so the web applications should not connect to the database using root or admin accounts. And you should limit permissions to only what's necessary. For example, read only for reporting dashboards. You can use a web application firewall, a WAF. So a WAF can detect and block suspicious SQL injections payload based on known patterns. So not a substitute for secure coding, but it's just an additional defense layer. And last but not least, we can keep our stack updated. So we need to ensure that our DBMS, programming language, and libraries are always patched. And many SQL injections vulnerabilities arise from outdated or misconfigured components. So let's try to do a little exercise on what we have learned in the slides. I will link the website in the description. So we need to access this bank and we know the username, which is this one. But we don't know the password, so let's try to insert, for example, hello123. And of course the password is not correct, so we get an error for invalid credentials. And let's see the logs so we can have a more clear explanation. And we can see that the credentials did not match because the password for that specific username is wrong. So let's try to, for example, see if the application is vulnerable to SQL injections. And to know this, we simply need to add a single quote at the end of the password. In fact, as you can see, we get an unexpected error. And if we analyze the logs, we can see that the error is different from the previous one because we have an invalid SQL query this time, because we have two single quotes at the end of the password. So let's see in a more clear way what happens with the logs, and I want to be sure that the application is vulnerable to SQL injections. So you can see that if I type in a single quote in the logs, we have something strange. So right now let's try to insert the query that we have studied in the slides. So the or 1 equals 1, and in theory this should work, and we should be able to access the database instance for that account. So as you can see, we have accessed the account for even if we didn't know the password, because we used the trick single quote or 1 equals 1 and then the comment. But even if we didn't know the username, for example in this case test at email.com, we could use this trick or 1 equals 1 in the username input field. In fact, if we type in or 1 equals 1 in the username field and we leave the password field blank, we should have access to all usernames of the database.